Hello, I am Jürgen Bellmann from SOFiSTiK. In this video I want to show you how to create brick volumes starting with SOFiPLUS QUAD areas. I started in SOFiPLUS defining some areas, and of course it is important to give these areas a specific group number. Here, group number 3. These are the master group numbers of the whole system. After a SOFiPLUS export, we get these areas here, and we want to extrude it into this direction. We can use the command TRAN from SOFiMesh A, where we can transform or extrude quad elements to brick elements. Therefore is here a property command x3. X means extrusion with 3 elements, 1, 2, 3. And we want to extrude the original master groups number 1, 2, 3 and 7, 1, 2, 3 and 7 to brick elements. Here the plane variable is set to 0. The created brick elements shall get the material number 1, that is concrete, and shall land in the group 301. Then we have to copy the original master areas here to this new position so that they can be used for the next extrusion. This is just the same command with TRAN, only we use quad elements and create quad elements, so they are only copied. Now they can be used for the next extrusion. In this next extrusion, we now use these copied master groups 11, 12, 13. That is 11, 12, 13 because plane is set to 10. We copy the quad groups 11, 12, 13 to brick elements. That is the next volume extrusion. And the same we do here with this area 16. The area 16 is also copied to brick elements, but with material number 5, that is steel. And on the top I want to have a loading area, so I created a beam element here, 16. And this beam element 16 is also extruded now to quad elements. So a quad can be extruded to brick and a beam to quad elements. Now how to handle the SOFiSTiK environment. We first go to our SOFiPLUS, we have created our areas and we make an export. After the export we can look to the animator and we see just only the master planes. Now we go to our extrusion. First I redefine the aquas for material, maybe nonlinear material. And we make a little SOFiMesh A extrusion. For this, please in the beginning start with only the first extrusion by inserting a double end line here, so only this will run. The first quad transformation extrusion. If I now run this little file and open the animator, we see that the first extrusion happened. If we now want to test the next extrusion, maybe the master blocks, we shift these end lines below. We first have to make a new export from SOFiPLUS so that only the master planes are in the database. Now we can run this next extrusion again. We see the first extrusion and the copied master areas. It is a little bit boring to always make here manually the SOFiPLUS export before the extrusion, so I can show you how to improve this. We make one export in SOFiPLUS. Then we go here to the database, export to DAT, SOFiMesh-C, and we get a teddy with the SOFiMesh-C input. We copy this and insert a new task with teddy, and in this task we copy the SOFiMesh-C inside. And now whenever we make here a change, maybe in this file, we can now calculate all, and automatically the SOFiMesh-C master planes are created, and then the extrusion with SOFiMesh-A runs. Now I remove these double end lines and again calculate all. Again, the master quads are created, and then the extrusion for the volume elements runs in SOFiMesh-A. If we now look to the final system, we see here our complete volume. I have here a steel plate with a loading area on the top, and I also inserted a quad bedding area on the bottom. Now we can make our first analysis. We define a SOFiLoad quad load on group 902, that is the loading area, and we just run this load case. Our first view usually is the animator, and we see here the deformation, loading, and here the results on our system. If you want to make a nonlinear analysis, there is a nice YouTube video, Cracked Concrete on Brick Volumes, in the internet. Now I show you some quick results on this volume elements. We best insert a task with the interactive graphics, and here we first look from the top. Maybe I now create a brick cut. Please first give a group number 1, and I say I want to have a brick cut created from here to here. And I go to another group number 2 maybe, and I want to have a new brick cut created from here to here. Now I can make a three-dimensional view, look to the results of volume elements. Here best 2D stresses, this is in the plane. Maybe I use the maximum compression strain in local x direction. And if I choose the ISO area representation, you see that I see here only the cutting planes. Now you can go to the group settings and say here, oh, in the moment I only want to see the cut number 1. Okay. And you see here the stresses in this plane. We can of course also look to the principal stress in the global directions. Here we see the load coming from the loaded area, going to the steel part, because here in this area I have a steel dowel defined with material steel, and here I have concrete. And we really see the difference in the stress in the steel and in the concrete. So that's all for the beginning. I have copied an ASCII file of the system to ASE.DAT English brick from SOFiPLUS to brick.dat. So thanks for listening and goodbye.